I'm going through the dam building segment today, and the piece of data that I'm using here is a full farm. This is LiDAR data and what it looks like. This is actually probably deceptively big. I'm just going to put a boundary on here. So that's actually, it was about 6,000 hectares. So this is a large piece of data, and as you can see, the thing we find handy with LiDAR data compared to tractor data is just that it has absolutely everything. And in the 3D view here, over on this side of the hill, there's a feedlot. You've got bits of creek in there. There's sort of, we're not constrained by edge of paddock to edge of paddock, particularly when we're working with the drainage side, I guess, of farming. Having a complete picture and not just pieces of the picture is really valuable to how we look at things and how we work with things. But today I'm building a dam, so I'm going to take this across to Google Earth. Just with the Google Earth tool in here, it doesn't matter what I call it because we're just having a quick look. It takes me to where we are. And the reason I'm picking this is they have a gully dam existing, but it doesn't have enough capacity. And so we're looking at a site around this gully dam to increase water holding capacity on farm. The first few things when thinking about storage is TerraDesign makes it deceptively easy, but there is a lot to think about. And on this site, if I'm looking to build a dam, I want something that's close, something with the least amount of pumping that I want to do. But what's most important is probably the soil types involved. And on this particular site, you can see this hill. It's a sand hill. Over here, we're going to do some electromagnetic survey to test the types of soils that are through here to see if this is a reasonable site. We're going to test this to see if it's a reasonable site, and it's down in the valley of here, and it's some better clays than up here in the sand hill, but we want to make sure that down through the profile is clay that's going to hold the water and not sand. And our other potential site that I'm going to use it as the example today is here. And the reason this one is a potential site is it's close to where our water is. It's a large enough area. With smaller areas, you get caught up in how much you can potentially hold. And that's for a few reasons, and I'll talk about those as I take this into design. So one of the things that we can do with TerraDesign is I can say, this looks like a good area. I'm going to draw a polygon in Google Earth, and that looks like a structure. So we're just going to go around that. I don't really care about existing turkey's nest because we're just going to earth move straight over the top of that. So this is my potential storage area. And I'm going to save this place. I'm going to save that polygon to the desktop. And when I go back to TerraDesign, I can, in the boundaries tab, because I want to use this as a boundary, I can import this layer, KML. I've saved it on the desktop, so it's easy, dam1, and I get a nice little boundary of the area that I wanted to cut out of my huge data set. When using big data sets like this, it's really handy to be able to cut smaller pieces of data out because it just makes everything run a lot smoother, and it's really handy to be able to do that from large data sets. So with the surfacing tools, there's a duplicate surface. We're just going to go to the boundary, cut out my piece of data, and there we are. I have a smaller set of just the area I want to work on, nice and handy here. In the guides, I'm going to use the contour tool to have a look at, just get a feel for my site. The color is one way to get a feel of your site in TerraDesign. But contours is a really targeted way, because I can sit here and I'm fussy with colors, but I can count here. These are 1 meter contours. So I know that over my potential site, I've got 1, 2, 3, 4, 5, 6, 7 meters of elevation change. Now this is a lot for a single dam site. This is no longer looking like a dedicated ring tank. This is looking like it's going to be a gully dam with a very large wall on this southern side where the elevation is lowest, and backing off back to pretty much ground surface over here. So I'm going to look at nearly no water up this end and 7 meters of water if I get to up here. So that's just something to keep in mind. The contours just give you an idea of how things are going to look. So now I'm pretty much ready to start on the actual dam tool. It's this one. It's a fairly new tool. And you start just by making the area. So I'm going to step in a little bit from my boundary. Trace where my dam is going to be. And of course, before we get to this stage, we've had a good think of, we've investigated the soils for their water holding capacity and for how, I guess, acceptable they are as a dam wall building material. We want a dam wall that's going to lock water inside, lock up tight, but also not erode or not have a chemical imbalance that's going to let water tunnel through those walls. We're going to, now that I've connected that line, I closed it there when I came back to my first point. You can create a full cut dam, which is a full flat borrow, or we can create a borrow pit dam. I'm going to do a borrow pit dam today. This is our dam creation window. There's a lot going on here when we first open it up, but we'll simplify that as I go. I also want, today I'm going to have the 3D open on my second window, just so you can see, I guess, live how using this tool changes what the things in here are doing to our actual design. And I'll turn off the original. So you can see with the borrow pit, it's pre-filled out with just some very pre-details. They've really got nothing to do with what I've chosen. They're just to get a start and to get a look. You can see that there's a dam wall in there, and there's a small borrow pit, and the floor's mostly getting left alone. Some of the places to look on this. This is a cross section. So if you're looking down the wall with the wall and the borrow pit, this cross section is modeling that roughly of what's going on, and it's giving us a few details. This section is at 0 meters. So if I went back to my original Terra Design screen, it puts a little yellow line in here and it shows you where that section is. And so I can add extra sections and put those at a new distance from our start, if our start is 0 here. So I might put one at 300 meters and I get a new section at 300 meters show up. But today I'm just gonna put one. I'm gonna put a few sections. So on a bigger dam, that doesn't have such an elevation change, I might only use one section to model one type of wall. Because I'm having this dam where this wall along the southern side has to be a lot higher than the dam over here, I'm going to model a few different sections of wall. So it's going to give me a chance to show you the tools across a few different sections. So I'm going to put one. You can see that's coming up around here. I want it more up here. So I'm just going to today play with this a little bit to get it. There we are. That's roughly where I want it. What I'm thinking here is I want this borrow pit to drain back to this point. because that's where the water is. The water is coming and going to our gully down here. And so this floor, well, most of it naturally will drain to the south. This borrow pit, if I dig it flat, it's just going to be one big flat ring that's always boggy, always wet. But as it dries out, I can put a slope on it and I can bring it back to a point. And that's why I'm throwing in my extra sections. There we are. I've got a section at the top, which is going to be the peak of my borrow pit, and I've got a section at the bottom, which is the base of my borrow pit. And now I'll talk a bit about, I guess, the template of each side and the things to think about. The outside slope. The outside slope on a lot of dams isn't the big consideration. We want enough here. Some farms might have, I guess, a safety aspect, and so you might take that back to something that you're not going to roll a ute down. But for the most part, a 50% outside batter is enough. Our height on this is one of the difficult things to have a guess at with height. It's easy on a flat floor, but our height on this one, we've got to get the height at the right point above natural, that we have a height the whole way around. And there's been an update in Terra Design. There's a few tabs here, the design, analysis, and some tips. But on the analysis side, we have what our zero height is at 301.08. So you can see on this cross section at 0, here, how do we know what 0 is when we have a really sloping site? And that's done for us through this analysis side. Because it's not 0s can be anywhere, but for the purposes of Terra Design, it is the average height of the line that you first put in, which is not something I can probably do off the top of my head just by looking at an image. So it's been a helpful addition. So we're going to go today, start with 3 and see where it takes us. And each section is its own section. And each section uses that same 0 height. So 3 meters, even though we're 7 meters higher, is the same height as 3 meters, even though we're 7 meters lower. And that's why it's a relative level and a frame of reference for our cross section. And that's why it can get a little tricky when trying to think on these steep slopes. Width of the top of bank. Width is a consideration on smaller dams as far as what kind of vehicle are you going to drive around the top of it, and less so for holding water. So you might think of a vehicle width, 3 meters, 10 foot to drive a ute around. As the dams get larger, you have to take into account the wave action that's going to be crashing against around near the top. You have to take into account the phreatic line of the water. That's if this dam is full and that water is slowly working on seeping through the bank, the angle at which it seeps through, and a wider bank pulls that more back towards the ground surface so that we don't have seepage. So smaller dams, the consideration is mainly trafficability. As the dams get more height, it's about holding that water inside the dam and knowing a width that is suitable to do that. At our highest point on this dam at 3 meters, I'm guessing that it's going to be about a 7 or 8 meter height above ground here. We can check that later, or you can do a hand calc between what you know that surface to be and what you know the 0 height to be. You can see I've got a minimum height here. So at 295, a 391 plus 3, it's going to be close to the 9 meters actually for a maximum height. That's getting quite high. So I'm going to take my height out to an 8 meter bank. Oh, not height. I'll take my width out to an 8 meter width. And so that is, just because I know at that kind of width, what I need. bank back slope and channel front slope. Because this is a borrow and dam type scenario, the borrow is called channel in here still, and those are the same. And I'm going to take that to a 7-to-1 batter on all of them. We can choose the depth of that channel, and as you can see, it's quite a deep channel at the moment with that 5 meters down there. The main consideration with a borrow, this channel, is we want to get, you can see the section of the cut fill. At a 2.64, we've got 2.64 times the amount of cut then we need to fill, and so it's about bringing these back to reasonable values where our overall cut fill is going to balance. And this is a new one because this looks confusing, but we still have a borrow pit up here because the natural surface is above our 0, 0 frame of reference. So even though I have a negative depth, my borrow is still a borrow. And that's where it can be sometimes handy to have the 3D view. You can now see that my borrow is back on natural surface here, and that I have a slope on it from top to bottom so that it drains to here. So that's the main tools in here. You have the ability to have sections around, so we can vary our dam on these. We have the ability to choose heights, widths of that top bank, slopes appropriate to the size. Smaller dams don't need the same inside batter. It might just be a small surge dam where there's not water often, and it could be a 3-to-1. By the time we get to some really big dams, you want to roll that right out to an 8-to-1 so that the wave action on that storage isn't eroding away at that wall. We get the excess of cut fills, and at the moment we don't have an estimate on that page of the full cut fill, but we do on the analysis. So we get to this point, and because we're on a large dam and wave action, I'm going to take my freeboard. That's the distance that water is going to be from the top of the dam to 1 meter. And that's important because of the fetch length on this. But we get some details. So we can see our total cut, total fill. I'd need a lot more cut. I'd need to work on that borrow to get things stored. But we can start looking at how much earth we move per megaliter. If you know your earth moving costs, you can now get a handle on how much you're costing per megaliter to build this storage. So it's a relatively quick tool, and that's a really valuable decision-making tool. We can do all the investigation, but if it's a bad site and the size of the walls versus how deep the borrow isn't making sense with the meters per megaliter, then we just go and we move sites or change the goalpost to make something that works. And we can see that we have a rough idea of the megaliters at different heights in the storage. At that point, that's our dam. It's made its surface. It's finished. We can, and that's ready to build a machine control file. We can do all the normal tools. If I actually make that a base surface that you can with other surfaces, we can get cut fill maps. We can put that straight to if it's the right design, put it straight to machine control and build it. James, is there anything else that you want to just touch on there?
That's all. No, that's all right. I will presentation. Okay. So thank you, Andrew, for the run through on the dam design tool and some of the considerations. And it is important, if you jump back early in your presentation where you said about analysing soil types and taking into the considerations for building a storage, it is very important for people who aren't engineers, who aren't regulars in building storages. It is important to consider a lot of variables when building storages, and potentially consult with an expert, because soil types, there's regional constraints, standards that need to be met. There's a lot of things that should be considered when designing storages and dams. So everyone should keep that in mind. Now, thanks, Andrew, again, and thanks, Jay. We'll jump forward here. So the educational resources on how to use all the tools are available on YouTube. These webinars are made available to review as well. Anyone that's registered to join these will see those. And yeah, follow us on our social medias as well to keep up with the latest news. Next week, wrapping up this series, will be best fit and multi-fit field designs and the chaining different design styles and tools together. We're swinging back to the in-cab tools for next week.